reproducibility in R programming, which are very quick and simple. So here I want to share some tips. How can we make the results in the paper reproducible? My suggestion is to use R Markdown because you can run the whole script by itself and to get every result, and you don't need to run the code piece by piece. So the first tip is to use init to run the whole script before writing down or plotting results. And the second is to clean the R workspace before reproducing results. And the third is to watch out functions that have internal randomness. And the fourth is be careful when you use parallel computing. And the fifth is to save intermediate results when needed. So I'll go over each one and see that. You can see that. So this is an example with a function that is internally random. This is the cross-validation function in the package GeoMNet people use for doing lasso, ridge, elastic net regression. So I first load the package, I set a random seed, and I generate some data. So here I'm generating the Y as the response, which are binary, 0 and 1, and X are continuous predictors. And I want to find the lambda parameter in lasso for doing penalized logistic regression. So I use this built-in function cv.glm, and I use it to find the lambda value that minimizes the overall cross-validation deviance. So this is the lambda value returned. But now you see if I run it for a second time, I got a slightly different lambda value. So I wonder how this result could be repeated itself. So what I did is that I removed the data generation. I still keep the same seed, remove the data generation. So I will use the same data I generated, but I run this function again for twice. But now you see this result I got for running it, even though I reset the seed, is still slightly different from this value. And the reason is that because in my data generation step, there is some randomness involved. Like I used the R norm to generate some random values from normal distribution. And here I use the binomial to generate values from Bernoulli distribution. So those randomness will actually occur before I run this function. So that will make me get different results, even though I'm under the same seed in the beginning. So that's the very big issue here. So to solve this issue, my first take-home message is that you never use the result produced by a local code chunk in your terminal. Instead, you should run the script from the beginning in a clean R workspace. Now you see, I start from a clean R workspace, run this part, and this value is exactly the same as this value I got here. So this is my first take-home message. If I just run this part by itself, the value will be different. And the second thing is that I have a better solution because this cross-validation itself is built in, its randomness is coming from the cross-validation. That is how you randomly divide your data into folds. So this function has an argument called fold ID, which allows me to specify the data folds before running it. So this can remove the randomness in this function. So what I did is that I set the number of folds to 10, and I first divide data into folds by doing this step. So that is for every data point, I will randomly assign it a label from 1 to 10. And this will become its fold ID. And I can save this ID so that for my readers who want to reproduce my results, they can just load this saved fold ID, and they don't need to repeat this random generation due to the different operating systems. Because my student told me that even if we use the same seed, but on Windows versus on Linux, the random number generator may be different. So that's why here it's better to save the fold ID and directly load it so you can get the same result. And now you see, no matter how many times I run, I can always get the same lambda value. That's the first example. The second example is another function I use in the Dorj analysis is the randomForest. So for this randomForest, it's internally a random function. And here I use its package, and I use this other package to get the AUPRC, area under precision recall curve value. So you see that I run it for twice, and the AUPRC value slightly differ. So the take-home message too is that if the function has internal randomness, and to know that, we need to have a very good understanding of the algorithm. And in this case, if there's no way to make the function deterministic, what we should do is to set a random seed right before running the function. So you see, if I set a seed here and here, running the function for twice, I get exactly the same result. Okay, parallel computing. This is another question. So often we want to use the multiple cores in our computer. And in R, there's a built-in function called parallel. And in the parallel package, there's a function called mclapply, which allows you to do multiple loops in parallel. So you can use this argument mc.cores to specify the number of cores to run. So here I'm specifying two cores, and for each core, I just randomly generate a shuffle the numbers 1 to 5. So you see, here are the two shuffles I get. And I set the seed outside. But you see, using the same seed, I run this again. The shuffles become different. This is quite surprising. And you may wonder, what if I put the set seed inside the loop so that on every core, I use the same seed? Now you see this works. I get exactly the same shuffle. But in practice, this is not really useful because the reason we do the loop is often because we want every step or every process in the loop give me different randomness. But if the randomness stays the same, that's often not the purpose. So the solution is that this mclapply actually use a different random number generator from the default. So in order to make the result reproducible, we have to specify the random number generator to be this one. So this is not the default one, but we can specify it to be this one. And then when you set the seed outside, you can get exactly the same result from mclapply. Okay, then out of my curiosity, I also check something else. After I run the mclapply, I want to see whether the random number generator stays the same, and it is. So it's still this one. So I also wonder whether this random number generator works for anything not in mclapply. So that's why I just said random seed and run this command. And I can see that it's totally reproducible, which means that this random number generator works in general, so we can use it. And what if I switch back to the default random number generator in R? This is the default. So I can use this command to switch back. And now when I switch back, under the same seed, I use the same command, but the shuffle become different. You see, this is 4, 5, 1, 2, 3. But using the other random number generator, I get 1, 2, 4, 3, 5. So this means that the same seed will give me different results under different number generator. So that's what's very important, that we have to make sure we are under the same random number generator and the same seed, so our results are reproducible. Okay, the take-home message 3 is that if you use parallel computing, be more careful about the reproducibility. And take-home message 4 is that for code chunks that takes longer to run on a laptop, we should set the code chunk. Actually, this is a typo. I think I corrected, sorry. This should be the EVAL, the code chunk option. It should be evaluation equals false and save the results to R data files. So once you do that, you can directly load the results and people can start reproducing the results from here without worrying about the randomness before. And also, if the code chunks take too long to run, it's not possible for people to reproduce them on the laptop. And take-home message 5 was something I borrowed from Hadley Wickham's blog. So he was the developer of a lot of very useful R packages, like the ggplot2. And so he recommended that we should include the output of session info as a comment in the R markdown, because this can output the environment, the package versions, you use, so people can clearly know the versions they need to reproduce your results. And lastly, if we are an advanced user, we should use Docker. So Docker is like a mini computer that is standalone. If you have a Docker, people can just enter the Docker or install the Docker and run everything inside the Docker. So this can guarantee that they have the same package version as you do. So everything is totally reproducible. So if you're interested in that, there is a website. You can go to here, and there's an R Docker tutorial that tells you how to start. So that's it. And also, lastly, for information, I make the slides using something called R presentation inside the R Studio. So the slides will be a set of HTML. So the nice thing for doing this, I think, is that you can just share the HTML link with people, and people cannot easily download the slides as a separate file for sharing, but they have to go to the link to get your slides. So it's a very good way to keep your slides permanent, and people cannot easily modify it. And that's it.